Hi, this tutorial is going to cover the often misunderstood subjects of resolution and image resizing. Don't worry if you don't understand it all straight away. Remember, you can watch the tutorial as many times as you like. The first thing to define is a pixel. Digital pictures, whether scanned or taken with a digital camera, are made up of a grid of tiny squares. Each square is a pixel and contains information about the colour and brightness of that part of the image. If you zoom into an image far enough, you can see the individual pixels. This type of image, made up of pixels, is called a raster image. We will look at the other type of image, a vector image, in a later tutorial. Now, let's get some definitions out of the way. Resolution is one of those words that means different things in different contexts. It's a bit like the word print. This could be a photographic print created in a darkroom, a colograph print made with a press, a screen printed image, or something printed on an inkjet printer. They are all called prints, but the word needs qualifying before you know precisely what it is. We'll start with monitor resolution. This refers to the number of pixels that are displayed by the monitor, for example 1024 by 768. The first number refers to the width in pixels and the second to the height in pixels. Each monitor will have a maximum resolution, and it can't physically display any more pixels than this. I'll just minimize elements for a moment and right-click on my desktop, selecting Screen Resolution. Here you can see my three monitors. The two right-hand ones are the same size. If I click on the drop-down list, you can see that the maximum resolution these monitors can display is 1920 by 1080. If I click on the smaller left-hand screen, then you can see that the maximum resolution for this one is 1280 by 1024. You can, however, choose to set your monitor to a lower resolution. If you do this, everything on the screen looks bigger. A higher resolution here means that everything is displayed smaller. I find as I get older that I'm more comfortable with my monitor at a slightly lower resolution than I had when I was younger. Now we have printer resolution. This refers to the maximum number of dots of ink or toner the printer can print per inch of paper. Be careful when looking at the resolution given in the specifications of inkjet printers, such as this one for an Epson S22. This printer has 4 different colour cartridges: cyan, magenta, yellow and black. Each dot of printed colour could be made up of overlapping drops of all these colours. So it makes some sense to divide the resolution figure given in the spec by the number of ink cartridges present. That will give a more realistic number to work with later when you come to print. By the way, the megapixel number in a camera specification is derived by multiplying the maximum width of the image that the camera can take in pixels by the maximum height of the image in pixels. At its highest resolution, my somewhat elderly digital camera produces an image 3456 pixels by 2304 pixels, or just under 8 megapixels. Image resolution has nothing to do with pixels per inch. This only comes in when you want to print an image. Next, we have image resolution. This refers to the number of pixels in an image. Lots of pixels means high resolution. A small number means low resolution. Of course, the definition of lots of pixels is changing over time. When I got my first digital camera, it took the then huge amount of 3 megapixels. Now, even my phone takes 5 megapixels, and reasonably priced cameras can take 20 megapixels. The last definition is of print resolution. When you want to print an image, the first step is to look at the size of the image to make sure it will fit on the substrate you want to print on. So, you either use the menus, Image, Resize, Image Size, or use the keyboard shortcut Ctrl, Alt and I. Here you will see two sets of dimensions. The top box refers to the image size in pixels. The bottom box refers to the document size, that is, the size the document will be when it's printed. This is made up of the height, the width and the print resolution. I've created a new blank document that's 1000 pixels by 500 pixels. I've kept the numbers simple so it's easy to see what's happening as we change settings. The print resolution is set to 100. Elements calculates that the image will print at 10 inches by 5 inches. In other words, it's divided the 1000 pixels by 100 to give a printed width of 10 inches. And divided 500 pixels by 100 to give a printed height of 5 inches. I've made sure that the Resample Image option down at the bottom is not selected. And now I'm going to change the resolution and observe how the dimensions change. Taking our image of 1000 pixels by 500 pixels, if the print resolution is set to 200, then the image will print at 5 inches by 2.5 inches. If the resolution is set to 300 pixels per inch, then the image will print at 3.3 inches by 1.6 inches. The number of pixels hasn't changed, but the size of each pixel has. The higher the print resolution, the smaller each pixel is squashed because it has to fit into a smaller space. If the print resolution is low, the image will spread out over a greater area and each pixel will be bigger. It follows, therefore, that if you have a low resolution image, one with a small number of pixels, and you want to print a big version of it, then each pixel will be big and the image may look blocky, or to use the technical term, pixelated. I'll go back to a print resolution of 100 ppi and I'll click on the Resample option at the bottom of the box. This time, when I change the resolution to 200 ppi, the print size doesn't change, but the number of pixels shown in the top box does. What is happening is that the software is inserting extra pixels. Elements is guessing what pixels to insert. This is called interpolation. Lovely word. Elements makes a pretty good guess at what to insert, especially if you're not changing the size a lot. However, if you increase the size considerably, then the image can become fuzzy. Interpolation is never going to be as good as getting original pixels by taking a high-resolution image in the first place. It's logical, therefore, to do as much resizing as possible with Resample switched off, so you're only working with the original pixels taken by the camera or scanner. Then, if you want to expand or reduce the image even further, switch Resample on. Elements will then help you by inserting or taking out pixels to give you the printed size and print resolution you want. There are two other settings to have a look at in this dialog box, but I'll open a different image to illustrate these. The first is Constrain Proportions. If this is ticked, then when you change the print size of an image, Elements will keep the aspect ratio constant for you. So, if you change the width, then the height will be changed automatically in the same proportion, so as not to distort the image. Here, if I change the height from 20 to 40, then the width has also doubled to keep the aspect ratio constant. On the other hand, if you want to deliberately distort the image, perhaps to make a long thin shape to print on a banner, then you would have to deselect this setting. Now you can set whatever print size you want, and Elements will not try and keep the aspect ratio constant. So if I change 40 height to 80 inches in height and click on OK and zoom out so you can see the whole image, you can see that it's distorted. I really like this, but it's individual preference. Just be aware that if you want to have constrained proportions off, you need to have resample image on, or it won't work. The remaining item is the drop-down list at the bottom. This holds a list of settings that you can choose from, depending on how you are resizing the image, whether you're making it bigger or smaller, and to some extent the type of image. Luckily, they have an explanation next to each one describing what each one is best for. If you remember from the explanation of printer resolution, I talked about the maximum print resolution to use, calculated by dividing the inkjet specification by the number of ink cartridges. Well, if your printer has a maximum resolution of, say, 360 dpi, then setting your print resolution in Elements to a higher number than this will result in a much bigger file, and may well result in a less sharp image rather than a better one. To finish this tutorial, I thought I would go back to image resolution to show you how the number of pixels affects the quality of an image when you want to expand it. To illustrate this, I've scanned a fern at different resolutions to give increasingly high numbers of pixels. I'm going to zoom into each version by the same amount, using Ctrl and plus, so you can see how the varying amounts of pixels affects the quality of the expanded image. Starting with the lowest resolution version, I'm going to zoom in 8 steps. 1, 2, 3, 4, 5, 6, 7, 8. You can see the pixelated result, the blocks of colour. Now if I move across to the next version on the next tab and do the same thing, 1, 2, 3, 4, 5, 6, 7, 8, you can see that the pixelation is much less. It's still there, but it's not quite as bad. Now if I go to the next version up, again, 1, 2, 3, 4, 5, 6, 7, 8. Now we start to see the improvement in the quality. There's virtually no pixelation at all, just on the very edges. Then if we go to the highest resolution version, and here we have a really good quality image. We could actually blow this up a considerable amount without losing quality. There's a table on the PDF document which goes with this tutorial, showing the numbers of pixels for each version and the corresponding file size. As you can see from this, increasing the numbers of pixels also increases the size of the image file. Although hard disks, memory sticks and so on are pretty cheap these days, you wouldn't have to have too many images at 252 megabytes each to fill a gigabyte of disk, so it is a consideration.